Hello and welcome to the BSidesDFW Hardware Hacking Village, lab number 3. In this lab, we will walk through photoresistors. I am Altbier and I'm going to walk you through the lab presentation and hardware and code to make this work. So let's start actually with the PowerPoint. So what is a photoresistor? A photoresistor is a type of resistor that is light dependent. So it takes in light, and based on the light it takes in, it will either have high resistance or low resistance. So in dark conditions, the resistance is going to be very high, in the millions of ohms. In bright conditions, very light conditions, the resistance is lowered. Usually it's around 100 to 200 ohms, but it varies based on the photoresistor you're using. And to that end, I'm going to show you the actual photoresistor that was included in the lab kit. These are the values for the photoresistor that I purchased to put into the lab kit. And what we have here are two numbers. The first number is the value of ohms in K, and the other one is the value of ohms in millions of ohms. So we can see that this resistor, when it's in dark conditions, that is very low or no light, is going to have 10 million ohms of resistance. When it's in bright conditions, this is 10 lux. And lux is a value that's used for light. It's a number of lumens. That is going to lower the resistance to between 100 and 200 kilo ohms. And obviously the brighter it is, the lower it goes. So that is the type of resistor that we're going to be using today in this project. And let us take a look at the circuit. So here's our circuit, and what we're going to do is we're going to wire in a 100 ohm resistor and an LED coming off of one of the digital pins on the Arduino. And then we're going to wire in a photoresistor between the 3.3 volt power output on the Arduino going to the analog input. And then we're going to also wire in a 10k ohm pull down resistor, just so that the analog port will have its value pulled down to 0 when it's not getting a value from the photoresistor, because otherwise environment variables like static in the air and whatnot could produce values on analog pins that we don't want to see. So the 10k ohm pull down resistor makes sure that it's at a low value unless we bring it higher with the photoresistor and the 3 volts coming off of it through the photoresistor. So let us take a look at what we're going to build here today. So what we're going to build is the LED portion is going to be just a straight 100 ohm resistor and an LED going to ground from a digital pin. That is going to be controlled or turned on and off with the photoresistor that we'll have, and we have that 10k ohm resistor as the pull down. So we have 4 components and a couple of wires that we're going to put into place here. We have all of the strip board connections laid out here, and I'll call them out as I'm putting components in. So let us go ahead and build us a board. So we're using the same strip board that we used in the previous 2 labs. So you'll see all of those components are still on the strip board. That won't interfere with what we're doing on this build because we're using different pins in different areas of this board. So don't worry about that. And we're using the same Arduino. So we'll put that aside. And we have these four components: the LED, the 100 ohm resistor, the photoresistor, and the 10K ohm resistor, and a couple of wires. So we're going to start with the 100 ohm resistor. And we will bend this into a nice U shape. And then we're going to put it into the 5 row here between L5 and O5. And I will use my pliers to pull it tight. Okay. And so let's get that soldered up. All right, so we'll put some tin on the solder, on the soldering iron. That way we tin our tip. And we'll take a look at that connection. Those look good. So we're going to cut off the lead wires. That way they don't get in our way or short out against anything. Looks like we got a little solder in one of those pads that we don't need it. Just remove that. Okay, so next we're going to do our LED. Now our LED has, it's a polar component that we have to be careful which way we put it in. It has the large pin, the longer pin rather, is the anode, and the shorter pin, which corresponds with the flat side of the LED, is the cathode. We're going to put the anode into port P5 and the cathode into Q5. And we don't want it to sink all the way to the bottom where the plastic is going to touch the board because it might melt the plastic of the LED. So we'll get it about there and we'll bend those pins out. And then I'll hold it to where that LED is not pressing on the mat while I'm soldering it. And let's take a look. Yep, those are good solder joints. So we will trim the legs. All right. And so now we have to bring this to ground. So we're going to be running a wire from R5 down to N12. And N12, I might have to squeeze it under that one. So I measured a wire that I think will work. It's about that long. Let's trim the plastic off of it. And then we'll bend these ends down so that they can go into the board. Okay, so R5, and actually I'm going to do the N12 connection first, since I got to squeeze under that other wire. Okay, those are in place. So now I'm going to solder them up. All right, those are looking good. This one has a little too much solder, getting too close to being a bridge. Let's take some of that extra solder off of there. All right, so I'm just going to trim those up a little bit since they are sticking out, and I don't want to stab myself. Okay, so now we have our ground wires in place, and that completes the LED portion. Now we're going to put in our photoresistor. Now photoresistors are not polar, so it doesn't really matter which direction we put it in. And where we want this to go is between G2 and G4. So G2 is the 3-volt pin on the Arduino, and G4 is the analog pin A0 on the Arduino. So rather than use wires, we'll just use the legs because it reaches, and I don't want it to go too low, too close to this button. So I'm going to hold it up a little bit to where it's about even with the top of the female headers. And then we'll bend those out. And we'll do something similar to what we did with the LED. I'm going to hold the board at an angle so that we're not putting pressure on the photoresistor as we solder it. Okay. Those look like good solder joints. Just confirm, yep. So we will trim these lead wires. And we have that guy ready. Okay, so now we want to deal with this 10K resistor. So the 10K resistor is going to go between B4 and F4. So if I look here, B4 is here and F4 is here. And what this is doing is taking the leg of the photoresistor that goes to the analog pin, and we're extending that analog pin with a 10K resistor that will then bring to ground. We'll bend those and solder that. solder. Ooh, ow. Yes, be careful where you put the tip of your iron. Alright, that looks good. So let's trim those leads. Alright, and now we just have to do a wire to bring that 10K resistor down to ground. And so I have a wire that I think will work for this. So let's go ahead and strip off some of the plastic. And this wire is going to go from A4 down to F14. Yeah. Get in there. There we go. All right, let's solder it up. That'll be our last connection, and then we'll start playing with the code. A little too much solder on some of these. There we go. All right, that brought us to ground. So that is our completed circuit. We have our photoresistor, which we'll be able to cover up to turn light on and off with it. And that, once we program it, should be able to program the LED turning on and off. So let us take a look at the code. Okay, so this first code, what we're going to do is we're going to define our pins, the LED pin and the photoresistor pin. We're going to set up a variable for the photoresistor values that we're going to read in. We're going to define the pin mode for the LED as an output pin and the pin mode for the photoresistor as an input pin. And you'll notice that's on A0, that's the analog port. We're also going to do a serial console at 38400 baud. We're going to set our delay time as 100 milliseconds. Then we're going to set up a variable for what I call a photoresistor threshold. This is the value at which we're going to decide whether to turn the LED on or off for. So if the photoresistor value is greater than this value, then we'll go ahead and turn the LED off. Otherwise, we turn it on. And so the rest of this sets up an analog read of that value. It prints it out. It determines whether the value is greater than our threshold or not, and it will either turn the LED off or it'll turn the LED on. And that's the basics of the code. We'll take a look at it in the Arduino IDE, and we can see the same thing. So we have our pin set up. We have our delay, our threshold, the analog read, and then based on the value and the threshold, decide whether we turn the LED on or off. And then we print the serial console, and then we sit at a delay to display that LED. All right, so we will do a quick verify while I'm getting my USB connected up. I am using a USB tester to plug this in. That way I'm protecting the port on my PC, which is very important. Go ahead and plug my Arduino into the board and get this plugged in. Oh, and it looks like this board is still running the code from LAB02, and that's fine. We can press the button and see that it's actually working with that code. But what we want to do is overwrite that code with our new code here. So we will go ahead and do upload. And now it has uploaded, done uploading. So it's uploaded the new code to the board. So now if I cover this photoresistor, you'll see the light go on, the new LED that we just put on the board. And that's what we wanted to have happen. Now let's take a look at the serial monitor so that we can see the values that are being set. And we see the p-value that we're setting. This is the photoresistor analog value, and whether the LED is on or off. And so we can see that it is changing as I apply light or not, or I mean apply dark or not. Now, in the beginning of this, I told you that photoresistors have higher resistance when it is dark. They're, let me pull up the actual page for it. It was under dark resistance, this particular photoresistor is going to have 10 million ohms of resistance. And under bright, it's only a couple hundred K ohms. So why then, when I cover this up and make it dark, are the values lower, you might ask? Well, that's because these values are the values that the analog pin is receiving, which is through that voltage going through the resistor. So when I make it dark, the actual value that the analog pin gets is less because the resistance is high. When the resistance is lowered, that's when the analog value goes up because there's less resistance, so more of it makes it through to the analog pin. So that's why it looks the way it does, if you were curious about that. So now you might ask, well, what are these p-values? These are just the straight values of voltage being received by the analog pin. And it's voltage that is applied with resistance, so it's not going to be that straight 3.3 volts. And so the analog pin is reading that out. Now, what we're going to look at next is how do we turn that into an actual value of light to be able to see light is measured in lumens. What is the luminosity? So the next piece of code that we're going to work on is just an extension of the code that we just did, and we're going to add some pieces of code to it. So we're adding some constants for our voltage in. We have to tell it what the beginning voltage in is, what the value of R7 is. R7 is the 10K ohm pull-down resistor that we're using. The defined variables, we already had our p-val variable. We're going to define another variable called lux. And actually, this is really small. Let me pull this up in the actual IDE. That way we can see it in a little larger text. Okay, here's the IDE version of this. So like I was saying, we have our constant values that we're going to set, and then we're going to set our initial integer for the p-value. That's the photoresistor value. But then we're going to create a new variable called lux, and that's going to be a floating point variable for the luminosity. And then we're going to do a conversion, a variable that does some math for us to do this conversion. We're going to call this floating point variable sensor raw to physical. And it's going to take an integer, which is our raw p-value that we're going to feed it later. It does some math to figure out what is the analog voltage, what is the resistance, and then what is that physical lumens value, and it will return that physical lumens value. So then in our setup, this is all the same. And when we get down to the main loop, we've added some code here to where when we do that analog read, we're going to print that value, and then we're going to set the lux integer, which is a floating, or not integer, floating point value, to that conversion value, and we're going to feed it the p-val to get the result. And then we'll print out what that result is, which is our light in lumens. And then everything else is the same. So let's go ahead and get this ready to load onto our board. Now physically, we're not going to see anything different on the Arduino, but in the serial monitor, we will see all these values printed. So I'm going to compile and push this to the board. It's uploading, and it's done. So you can see this works just the way it did, but now we're going to open up our serial monitor, and we will see more values. So what we see is the raw value. That's the what the analog is actually reporting, that analog pin. And then we've converted that to lumens of light. And then as we cover it, we can see that the lumens drop. And we can see it's not an integer type drop. There's always a little bit of light leaking around it or outside of it. And as I bring this closer to a light source, it gets brighter. And then pull it away from a light source, it gets dimmer. So that is how we can read the actual values coming off of a photoresistor and turn it into the lumens of light that is recording. Well, that is the end of this lab. I appreciate you attending, and I hope you attend our next lab in the series. Thank you.